Hello students, we are now discussing question number 91 of KVPY SX 2021. This is the first question of part 2 of physics, and this question troubled a lot of students. Let's see what is present in this question. So this question says that a drinking straw is dipped in a pan of water to a depth d from the surface, as we can see here. Now water is sucked into it up to an initial height of h naught and then left to oscillate. As a result, its height y from the surface of the water varies periodically. Ignoring damping, the equation for y is. Now there are a few things to notice in the statement, all the statement. So first is that the question never mentions the value of surface tension, which creates some kind, like generally what the students thought when they read this question was there is a straw involved, so surface tension must be involved, but the question doesn't mention it at all, and in the equation also it doesn't appear. So in all likelihood we have to ignore surface tension. That is first point. The second point is, why did they use the word pan? Why not a cylindrical container? Or why did they use the word pan here? So the most likely reason is because we generally imagine a container of large area, or you can say a larger area, when we talk about a pan. So what we intend to mention here is that the cross section area of the straw and the cross section area of the pan, they differ from one another in a manner that A is much smaller than A. So most likely the reason for using the word pan is this. Okay, the question clearly mentions that damping is not there, and the question is asking for equation of y. Now there is one more thing that you must think about is, why are they asking about equation of y? For example, let's say if this would have been the answer, let's say if this would have been the answer, wouldn't it be better to ask omega, because this equation represents the equation of SHM. So why not talk about some property of the system instead of simply asking the equation? Because if the question asks about a property of a system, for example the omega or the time period, then we have to go one step beyond this also. Like after framing this equation, we have to compare it with the default equation of a system, and then we have to get to the answer. So why they are not doing it? Probably because we'll end up with an equation which is difficult to solve, and they don't want to check us on the mathematics, like mathematically it is too complex to solve at our level. So that's why they are probably asking just to frame the equation, not to solve it. So what my thoughts were when I saw this question first time, I will share those thoughts with you. I will share my thoughts honestly with you. Why am I saying that I'm sharing them honestly with you? Because my first attempt wasn't the correct one, but I'll share my thought process with you. So I began like the statement that we have to ignore damping. This statement motivated me to think about conservation of energy, or to look for energy equation except anything else. So how I started, let me tell you that, and where it led me to, let me show you that, and then let's see that what subsequently what I thought. So I started like this. I started that, okay, let's say we have a container, a pan, okay, and in the pan we have dipped a straw. All right, so let me just make the figure. So let's assume that this is the level of liquid. I don't know whether they mentioned water or not. Yeah, water is mentioned. So this is the level of water, and we sucked water up to a certain height. So I'm denoting this height as h naught, as the question mentions, and this depth is given to us as d. Okay, now once we release the water after sucking it up, let's say we have released the water, then it will begin to fall. Okay, during its fall, let's draw a general instant. So during its fall, let me just draw the figure, then I will tell you what I'm thinking. So I'll draw a level little low. So this is y. This continues to be d. Okay, now what I'm thinking is that as the level of liquid is falling, what is happening to the level of liquid in the pan? Well, strictly speaking, you would be inclined to believe that the level must increase, and that would be the right thought also. But given the assumption that A is much less than A, we can say that this level practically remains where it was. It even if it's moving, the movement is so slow, we can practically imagine it to be at rest, which brings me to the point that this portion of the liquid is at rest, like this liquid is not moving at all. Okay, so if I have to write any term involving kinetic energy, I would probably use only the part which is in the tube, because that is certainly moving. Like if this is coming down with some velocity, then this is also coming down to the same velocity, this is also coming down to the same velocity. So all the liquid which is present in the tube is moving. Okay, all the liquid. So what I plan to do, I plan to write energy equation. Like if this is initial instant, if it is, this is a general final instant, then I plan to write ui plus ki is equals to uf plus kf. So this is my intention. And to write uh, what I will do, I will treat this level, the bottom level of the straw, as the datum, or you can say as the level where we are assuming gravitational potential energy to be zero. So looking at the initial figure, I will write the gravitational potential energy of the water which is present in the straw. So how do I write it? I will first write the mass. Mass will be density into volume. Volume will be H naught plus D into A, where A is the cross-sectional area of the tube. So this becomes the mass, mg. Now, the height of the center of mass will be, the height of the center of mass will be half of, it will be half of H naught plus D. Okay, so this becomes ui. Ki was 0. Uf can be written in a similar manner. We just have to replace h naught with y. So I will do that directly now. So it will become rho naught, or simply rho basically. Okay, it will become rho into y plus d into a into g by 2 into y plus d. Now what about the kinetic energy in this state? So kinetic energy we are going to write as, I'm taking it here guys. So kinetic energy we are going to write as half into mass of the liquid present in the tube, which is rho into y plus d into a. So m v square is y dot square. Now there are few things to understand here, or we have to consider this. Why am I considering kinetic energy of only the liquid present in the tube? Because rest of the liquid is not really moving. Like what is happening, the liquid is coming from here, it is coming down, and right after it comes out of the mouth, we are assuming that the liquid is getting like it is moving to the other part of the container, but the parts are the area is so wide that the increase in level of the liquid is practically very slow. So you can just say that water comes down and then suddenly it loses all the speed and it spreads. Something of that sort is happening, and that is where I erred in my thought process. Like I'm talking about this now, but eventually, like initially when I did the question for the first time, I missed this part, that in this solution what I've assumed is that the water in the tube is traveling, and then suddenly the bottommost point, like in the next dt seconds, the vdt amount of liquid that will come out of the tube will come to rest. So this sudden coming to rest is actually a place where we are losing energy. Basically, it is tantamount, it is equivalent to suffering a collision. Collisions are nothing but sudden changes in velocity, and my solution is assuming that it is happening, and therefore this did not give me the answer. Like what I did, the next step was to differentiate this one. I will finish what I did so that you guys can also know, if you committed the same mistake, you should come to know what is wrong here. So if I write g by 2 like this, g by 2, and then rho will be there, a will be there. So g by 2, rho is there, a is there, and then h naught plus d square is there. Okay, so this becomes equals to rho a g by 2, then y plus d square uh, plus half rho a y plus dy dot square. So this is what our equation is. Now let me differentiate this equation. So g rho a by 2, 2 times of, see all this part is constant, right? All this part is constant. So let me just simply equate it with 0 is equals to, here we are going to get rho a g by 2 into 2 times of y plus d into y dot plus 0 plus rho a by 2, and then we'll go with the product rule. So y dot square into y dot plus y plus d 2 times of y dot y double dot. So this is what we are getting. Now for simplification purpose we can take out rho a, this This can be taken out as the common quantity rho a by 2. And what else? I think y dot can also be taken out as the common quantity. So we will be left with 0 is equals to 2 times of y plus d into g plus y dot square plus 2 times of y double dot into y plus d. Now let's have a look whether we have such an equation in the option. So first thing I will notice the coefficient of y double derivative. So this is certainly not the option. Y double derivative into y plus d. So y double derivative into y plus d. So these two options does give me a sense of familiarity, but 2 times of, so y dot dash, I don't think any of these options are matching because I don't see any y dot in this. So this is wrong. This is wrong. Now here y dot square is there, y dot is there, but the coefficients do not match. The coefficients do not match as you can see here. Like if I get this in the correct form by dividing the entire equation by 2, then we are missing a by 2 here. So going by this method, I could not get an equation which matches with any of the options. Now, what was the fallacy here? What was I missing? I was missing this point that the liquid which is traveling in the tube is traveling with the finite speed, and suddenly some part of the liquid loses the energy. It comes to rest suddenly. So that means we are losing energy because it's equivalent to an inelastic collision. So what should we do then? Like, is there any recourse that we can take? Of course, instead of going for energy equation, because whatever assumptions we are making, they are implicitly pointing towards loss of energy. So we cannot use energy conservation. So what can we really use? We'll go with momentum equation. Okay, instead of energy equation, this is something that we do on a regular basis. Like whenever we are faced with a situation in which we are losing energy or energy is not conserved, then we tend to resort towards momentum conservation. So let's try that. So how do I plan to write momentum conservation? So I'll begin by making the situation at a general instant. So and then I'm going to make the situation at dt seconds later. So let's see what I'm planning to do. So let's say liquid was present in this volume, and it was up to level y at certain instant, and then it increased to y plus dy in small interval of time. The question says that water will oscillate. So of course there will be a stage when liquid or water is going up in the tube. So this was the figure at time t. Let's say this is the figure at time t plus dt. So this level will be slightly higher. We can call it as y plus dy. Okay, and also if this was traveling with upward with the speed y dot, okay, then this is now traveling with the speed of y dot plus d of y dot. Okay, so let's now write the equation. So I plan to write momentum in the initial figure. Let me call it as x, and let me call this situation as y. So I plan to write momentum in x situation. And how do I write that? So again, I will still assume that only this part is moving. So the momentum will be written as density into volume. Volume would be y plus d into cross-sectional area. So density into volume, that's mass. Mass into y dot, that becomes the momentum in the x situation. Similarly, momentum in y situation can be written as, again, density into y plus dy plus d. Y plus dy plus d into a into y dot plus dy dot. Okay, so this is how we write the final momentum. And now the impulse part. So which force is exerting the impulse? Let's try to understand. This is a subtle point again. So let's say in a general container, a simple container, liquid is at rest and the liquid continues to be at rest. In this situation, if I ask you the net impulse on the liquid, are you inclined to say that it is going to be zero? And if you are inclined to say that, then your answer is correct. What is happening here? This water is being acted upon by mg in the downward direction and by small normal forces here which balance out mg, and these normal forces, they become the cause of overall like the normal which will balance mg. Okay, this is what is happening. Here what is happening, like uh, the the part of the liquid which is assumed to be at rest, that is fine. In fact, any liquid which is above this the level of the water, that liquid is actually responsible for impulse. Like if there would have been no water in the tube above the level of water outside the tube, then all the water would have been at rest. So the impulse that is there, the reason for the change of momentum is this excess water. So what do we write as impulse? We write rho, that is density, into y, into a, into y dot. So this is what we write for impulse. Actually, slight mistake. I wrote momentum, like, sorry, I wrote the momentum. Impulse we are trying to write. Impulse will be density into volume of liquid above the tube, above the level. So that's this much. So this becomes mass. Mass into G. That will be the impulse that we are looking. It's actually force and then dt. So this becomes the impulse that we are looking for. Okay. All right, so now we will write the impulse momentum equation. So impulse momentum equation will be I is equals to Py minus Px. So let's do this now. Okay, so if I want to write it, see, rho and A, they can be taken out as the common quantity. This rho A, this rho A. Now I will write y plus d plus dy into y dot plus d of y dot, okay, minus y plus d into y dot. Now notice carefully, are we in a position to say, hmm, this bracket is not needed actually. Are we in a position to say that y plus d into y dot? So from here, from the first quantity, I'm considering this as one quantity, this is another quantity. So we have two quantities in the bracket and two quantities here. So 2 into 2, four quantities we are going to get. Out of these four quantities, one is going to get cancelled with this. So that was y plus d into y dot. So what we are going to be left with is y plus d into dy dot, into d of y dot. This is what we are going to be left with. And the third term will be dy into y dot. So dy into y dot. And the fourth term will be dy into dy dot, which we can ignore. It's going to be a very small quantity, so we are going to ignore this. So now if I write here, impulse was how much? It was rho y a g dt. Is that right? Rho y a g dt. This becomes equals to rho a and bracket start and then y plus d into dy dot, into dy dot, plus dy into y dot. Now what we are going to do, we are going to bring this dt on the other side. Okay, so if I bring this dt to the other side, so this becomes dy dot by dt and this becomes dy by dt. So eventually what do they become? Also rho a gets cancelled, so we are left with y into g is equals to y plus d into, this is nothing but double derivative, so y double derivative, and this is what, again this is the first derivative into first derivative becomes square of first derivative. So now we are looking at equation like 0 is equals to y plus d into y double derivative plus y dot square minus gy is equals to 0. We've already written it here. So let's see if we have an option like this. Let's see if we have an option like this. So here we see, guys, there is one thing, I think I committed a mistake, a slight mistake here. The impulse will have to be negative. Like I'm considering upward as the positive direction, mg force was in downward direction, so impulse should be negative. So I add here, so impulse should be negative, which means that the positive sign should appear here. I realized this when I saw the option here, because this option still doesn't match. We can see that option 4 matches once we do this, and that was logical, so I committed a mistake there. So now we see that option D was correct. So that is it, guys. So the honest attempt, my honest attempt was in which I tried the energy equation first. Good thing was that it did not match with any of the option that was given to me. Otherwise, I probably would have went ahead with that answer. Not that it would have cost me any marks because I did not write the exam, like I did it at home. But the point is that since none of the option matched with with what I got using the energy equation, so it prompted me to think in some other manner. So I went ahead and I thought about the momentum equation. Also, it then became clear to me that the manner in which I was applying the energy equation, or the situation that I assumed to apply the energy equation, actually uh, told me, or the situation couldn't have ensured that energy is conserved, because there was sudden change in velocity of some portion of the water on a continuous basis. So that would have certainly led to some kind of energy loss. So I hope you enjoyed the solution. I hope you understood the solution, and this was a very good question. And now, once we get this equation, we understand that why the question was asking the equation and not the solution of the equation, because the equation that we are getting, it's quite difficult to solve this one. All right, probably you have not learned how to solve this equation by now. So good thing, good question. Uh, this question created a lot of confusion. Like, students found it difficult to address. Even after coming out of the examination hall, they were still struggling with this question. So I hope that I'm able to put your queries to rest regarding this question. So I hope you like the solution, guys. Vedantic Club is something, if you don't know, then you must Google search about it and you must inquire what it is, because you may just stumble upon something which is very, very useful to you. And this is a QR code. Scan this QR code and you will be updated about batches which are run by Team Clever. And if you get admission to these batches, which of course happens after a certain selection procedure, but if you get selected to these batches, then you get very, very high discounts and scholarships also. With that, I'll close this video and I'll see you in the video of the next solution, guys. Take care. Bye bye.